back. This probably should be the last one. Might be an extra one for this one, depending on how fast I can do this. But okay, so we have all our simple AIs. Manny's facing that way. I didn't realize Manny was doing that. That's fine. Bob is fine. Quinn has been like our more advanced AI this entire time. I forgot about that. But we're going to set up the same thing for Quinn that we did. We're going to set the same thing for Manny and Bob that we do for Quinn. Quinn is actually using a behavior tree to use her AI. So if I find where that is, for Quinn, who's over here, she's, it's easier if I just do it, I think, and then I'll explain it as I go along. Eventually, we're going to be using this AI controller class that we never got to use yet. But we did assign them for Bob and Manny. So if I go to class defaults, look for AI, we can see at the very beginning of this, we assigned our AI controller class. We just never did anything with it. So I'm actually going to close my other windows just to make sure they're not confusing. And we're working between, oh, that's Quinn. I thought you were Bob. Working between Bob and Manny. So what we're going to do is, instead of having them run using on the onBegin play, I'm actually going to unhook this by holding Alt and clicking this. That'll make the noodle go away. I'll do it for Manny as well. We're going to, and if you double click, you can add like a reroute node. So that's just like for, in case I want to reconnect it, I know that's what that goes to. So that means like right now, only if I press play, only Quinn should hunt me down. Yeah, because we unhooked the other two. But we're going to be working in their behavior tree. So if I open up the behavior tree, I just closed it just to, start fresh. We can see we have our Blackboard connected, which we already made. It's right here, and we just set it over here. And I started talking about this a little bit last video, but a behavior tree is just, it's what's acting as like the brain of like what decision it's going to be making. And what we're going to do is that we have these compositors that we can select for. These are like the most basic things we can do for the tree. And normally I like to do, a root and a selector. This will select which side to go left or right down the tree. We can hover over this and we can see like the selector executes their children from left to right, as I mentioned last time. And we'll stop executing its children when one of their children succeeds. If a selector child succeeds, the selector succeeds. If the selector child fails, the selector fails. So that means it'll try to go here first. It'll try to do this. This is considered a child of the selector. It'll try to do this. If it succeeds, then that's all good. And if it doesn't, then it'll go and do like its right branch. And I normally never use selectors in sequence. I don't really use simple parallel. I haven't had a reason to do it yet, but I believe you can consider this like a for loop kind of thing. Like it'll try to do this section while this one has not completed yet. But I've never actually used that one, so I'm just gonna kill it. For a sequence though, let's see, a sequence node executes their children from left to right and will stop executing its children when one of their children fails. And if the child fails, then this thing fails. And if all the children succeed, then this one succeeds. So we can add, I'm just gonna make some random ones. I'm gonna add some random tasks. It'll try to do this, and do whatever one's next. And it's line, I don't know if there's a limit. But if one of these fails, whole thing fails. And if they all succeed, then this all succeeds. So I'm just gonna delete them. Then what we're going to do is that we're going to make our own task, and we're going to make a random task, or a random move around task. So I actually already have one. It's right here. And this is what we're going to try to make. So I'm going to delete it. To make a new task, you click this little new task button up here. And you wouldn't have this one. This is one I made. But if we click BT task blueprint base, we can create a new task. I'm going to right click, make a folder, call this tasks. I'm going to shove my tasks in here. I'm going to call this BT task random move to random location. And I just hit enter, and what it did, it took me to my task. And there we go. Move to random. I actually don't know which one it is because I don't know. I can't spell. Move to random location. Okay, so this is the correct one. So I didn't spell the first one correctly. That's on brand for me. Okay, so in here, we can kind of access different stages in the behavior. I don't know if it's right to call it the behavior lifecycle, but we can do cool things. So if I click on override, we can see if our node has been aborted, has received an abort command, has received an execute command, or is currently running. I should actually read these to see if I'm saying these correctly. For abort, if both generic and AI event versions are implemented, only the more suitable one would be called. Sure. Okay. Receive abort. Yeah. Okay, that's fine. What's important is that I believe execute and tick are like kind of like a event begin. Execute is event begin play for this one, and tick is like it's event tick. So I think abort is when it's destroyed or canceled. But we want the execute AI version, not the regular one. Because I don't really know what the regular one does, but that's fine. And what we want to do is, let me look at my other one to see what I did, because I forgot. Let's see. This is my original task. Okay, so we're going to do this block of code. Let's see. We are going to, from the controlled pawn, we're going to get its active location. We're going to get a random reachable point in the radius. So this will be like in our nav mesh. We're going to look for, it's going to try to go to a random point that it can reach. And it's going to move to it. And then we're going to tell our behavior tree we have succeeded, if we succeeded, and fail if we haven't. And that should be checked off. So let's do that. So from the controlled pawn, let's see, I'm going to get actor location. I'm going to drag off of here. And do I want to do this? Maybe get reachable point in radius. And we want this one instead of the get reachable point in navigation. Get reachable point. Well, we want this one instead of the navigation one, because I think, if we're not mistaken. Let's see. Reachable would, like, if this was like a platform, this is like just a cube, but like if the platform, if there's a platform here and it was green at the top but not on the sides, this is still reachable but not navigable. It's very weird. I'm actually not that good at explaining it. All I know is that we really want this one instead of the other one. I think both will work, but it would change like where your AI can reach. So we're going to make this a variable for radius, just so we can like expand its radius of what it considers to be reachable. And from its random location, we're going to get the AI move to node, like we did in the original version. So it all ends with this AI move to node. Oop, wrong one. I'm just going to connect these together. We're going to get, for the pawn, it's the pawn that we're currently using. And accept its reading. I'm going to make this a variable too, so we can change what it considers to be, you know, acceptable. What it considers to like have reached its destination. And last thing we have to do is that on success and on fail, we have to tell the behavior tree that it's finished. I'll mark it as success. I'll duplicate this and I'll mark this one as a fail if it failed. Because in the behavior tree, it has to know, like, did my children succeed or fail, which is kind of weird to think about. And now we can just assign our task that we created. And last thing we have to do is that back in the task, we're just going to make these, that's the wrong task, make these variables editable in the behavior tree. So I'm going to make this I open. And this is like setting up a variable to be private or public. The I open means it's public. I think they call it instance editable in Unreal. Yeah. But now in our behavior tree, we can see we have these variables available to us. Let's set this to, what did I do the first time? I think I said it's like 1,000 and like 500 or something. And you can mess with these values to see like which one, that's not correct. What your AI is going to consider reachable. What I said to you. Yeah. 1,500 and 100. Okay. And if I really wanted to see what these things do, so I tested this before and these numbers worked good enough for me. But if I really wanted to see what these do, I could like mess around with them. Like I think if I set this to 0, it would stop like almost on whatever thing it's trying to reach. For this one, I forgot why I set it to that, but I can find out if I really cared. The last thing we have to do is that we have to tell our AI to use the behavior tree that we just set. So in our AI controller, which I know we haven't touched in a while, but just as a reminder, we set this up in like the first video. If I type in AI over here, we see we already set it. So we're kind of just saying on event begin play, behavior tree. We're saying just run the behavior tree that we're going to give you, which will be our BT NPC 02. So instead of using the event begin play, the simple AI move to node, we're running the behavior tree, which we've set. And because Bob and Manny are both using this one, they should move randomly around the map when we play. So let's give it a shot. Yeah. So they're not hunting us down like Quinn is. That's a different feature. But Manny and Bob now, have some life to them. Now, well, life, they have some stupidity to them, but they are doing what we want. Cool beats. Yeah, so that works. So the last thing we have to do is the hunt down feature, and give me one sec. I wonder if I can do this really quickly. Okay, so I probably won't be able to do the hunt feature in this video. I normally only do 3 for these, so I can keep you guys' attention. We'll make sure I'm not taking too much of your guys' time. But I'm gonna do the chase down feature in the next video, and that'll be like a short, like 7-minute video. So I'm gonna end this one here, and I'll see you guys in the last video.